All right. Functions basically, sometimes you use commands in Python that you know what the inputs are and you know what the outputs should be. However, there is this black box. You don't know what's inside. Usually what's inside is something we call a function. A function is basically a code that you call that will produce results for you. Usually, you know what's the purpose of this function. For example, we'll start with writing a code of an average of a function that computes the average of three numbers, for example. Most important thing, you know the inputs and you know the outputs. You know what I mean. You know their data type, like their range of values, and so on. So you should know the nature of their types, but the actual values is not mandatory. All right, so we will design with functions. So explain why functions are useful in structuring a code in a program. Now employ a top-down design to assign task functions. So sometimes basically your code might have multiple functions. Right now I'll show you some codes of my research that I basically use functions. It's just a task that I usually perform. So instead of writing its code every now and then, I'm just calling that function. So a function packages an algorithm or a code in a chunk of code that can be called by its name. So functions must have a name. Any name you decide, as long as it's not a reserved word and follows the naming rules of Python. A function can be called from anywhere in a program code, including code within other functions. Okay, so a function can receive data from the caller, and that's what we call arguments of the function. When a function is called, any expressions supplied as argument are first evaluated. Usually, most of the functions that we do must have this keyword return value. Basically, the function that will compute something must give values. Like I'm doing a code to find the average of three numbers, so I need to return the average. All right. Functions is like an abstraction. Basically, abstraction hide details, like what I mentioned here. You have this black box that has a detailed function. But for you, you don't care about what's inside. All you need to know that I feed it these inputs, I'm getting the output. As long as this code is correct. But if there are some issues with the code, no, in that case, this function is not useful. Function should have a proper code that return proper values. Okay. So we use abstractions to refer to the most common tasks in everyday life. Like an expression doing my laundry. Doing my laundry has a lot of things that I need to put them in the basket, put them in the washing machine, take them from the washing machine, put it in the dryer, and take it, and so on. But this doing my laundry did all that expression. So that's an abstraction. Effective designers must invent useful abstractions to control complexity. All right. So this is an example of a summation code that you put a lower bound and upper bound, and it will compute the summation of all values there. So let's not start with this one. I'll start with the easy function. Let me open Spider. Spider. Okay. Okay. So summation must start with the keyword def. Define def. So let me open the magnifier so it can be clearer. All right. Def what? Then the function name. So averaging, I'm going to call the function averaging. Now this function must have inputs. We call them arguments. Now I want an average of three numbers. Def is a keyword in Python. It means that I want to start writing a function. So define. And the function has a name. The function name here is averaging. So define a function, create a function called averaging that receive inputs, like these arguments between the parentheses. Now I want a function to find the average of three numbers. So I'll call it number 1, comma, number 2, comma, number 3. I'm not writing anything. I was writing, this one was there. So num1, num2, num3. So there you go. I define my inputs, and I should end with a column. Then I start writing my code related to this function. Now, first things, num1, num2, num3, they don't have to have values. The values will be when I call the function. Like right now, those are just variables. How to find the average of three variables? I'm going to call it avg equal num1 plus num2 plus num3 divides over 3. And that's it. This is the average. Now I'm ready to return the value. The function should return what? The average. That's it. That's a complete function that I started with def. The function has a name called averaging, has three inputs, num1, num2, num3. And computationally, the average equal num2 plus num1 plus num2 plus num3 over 3. So the average of all three numbers. Once I'm done, return the average. Okay, so let's try the function. First thing, how to call the function. I know this function must return a value as the average. So avg equal averaging. And see, that's a feature from Spider autofill. Now I need to fill the values. If I don't want that, like I should write the word averaging. Now what are the numbers? 5, 10, 15. And that's it. I call the function, the one that called averaging, but I have the inputs as what? 5 for num1, 10 for num2, 15 for num3. When I do this step, averaging 5, 10, 15, it will go to this function averaging here. Num1 is 5, so positions matter. Num2, 10, num3, 15. So I have them there. Now it will go to the code. Average equal 5 plus 10 plus 15 divided 3. Return what? The one I just calculated, average. Now don't get confused. This one has nothing to do with that one there. So I'm going to call it average, the whole word, average. Now let's try. Okay, I'm going to execute this portion of the function. Then I'll calculate the average. And there you go. The average. Okay, let me remove the minimum, maximum. Magnifying tool, and there you go. So here, averaging of 5, 10, and 15, when it did calculation of this code, num1 plus num2 plus 3, so 5 plus 10, 15, plus 15, 30 over 3, that is 10. So you go here, value is 10. If you remove this average thing, means what? I call the function and I'm not assigning it to any value. So I'll remove this variable here. So if I have it like this, averaging, okay, I need to call this one. Now let's execute it. It did print 10, but since I did not assign the value, there is nothing here. You comment to this, nothing will happen. This function does not return any value.
What is the return?
Return average. Return is a keyword. Average is the variable that I used. So in the upper line, I have average equal num2 plus num3 plus num4, num1, num2, num3 plus 3 over 3. So return average means this function will give me this value in return when I give it these inputs. So return this average. Now I'm gonna remove this return. So nothing will happen. So let's calculate here. Okay, this function basically does nothing. And if you put a word here, average equal, it will give you an error. It should give an error or a non-type because the function did not return anything. So I created a variable that has nothing because the function did not return a value.
Well, the value of the first line should be the same in the second line of the function. And number one and number three should be the same used inside, right?
You mean here?
Yes, I mean, here we should run number one and number three up, down.
Oh, yeah. There should be values I'm getting from the inputs because
the number of Java that we have XYZ inside the function. It will substitute.
no, see that, yeah, you can substitute here. You can, but we'll start with something simple that these values are being taken from the inputs. Now, sometimes I need the square of that value. So I can write somewhere here a formula that will change that value. But most importantly, these variables, when I call them, they have values. Where did they get the values? From my inputs here, 5, 10, and 15. Now let's assume one by mistake forgot a number. And let me do the return average thing. So this is a function. And averaging 5, 10. What about the third one, num3? Is it there? So I'm expecting an error. It's missing one positional argument. It's missing one input. So you cannot find the average of three numbers if you don't have the value of the three numbers. Is it clear?
Well, we have 100 equal x plus 120 over 3
Instead of num1, num2, num3? No. Like here? X? No, give it with X. Let's clear everything. So initially, before running the code, you see the line here. What is X? All right. Now I'm missing this. So let's see. Now I'm going to do it again, and I have the average value 10. So let's say sometimes in my code, I have default values. Like default values, the gravitational accuracy, usually it's 10 in physics. But sometimes people prefer 9.8 instead of 10 because the actual value is 9.81. But we approximate it to 10. So what some users do, they will say like, you know what, I'm going to give it a default value and it's up to the user if he wants that default value or change it. So for example, num3 equal 5. Okay. And I will calculate it. I'll calculate it first with 15. And let's clear everything. So what happens here, when I call the function averaging, it will take these inputs, 5, 10, 15. So 5 for num1, 10 for num2, 15 for num3. So basically this 15 will override the 5. It's as if this 5 did not exist. So let's execute it. Average is 10. When this one will take effect, if I'm not putting a value there, it says that num3, its default is 5 if there is no input was given for num3. Otherwise, you wait for, otherwise it will be 5. So here in this case, num3 equals 5. Now I'm doing averaging 5, 10. By position, 5 is for number 1. 10 is for number 2. Number 3, is there any value for there? So it will take the default 5. So let's do the averaging. And what is the average? 5, 10, and 5. So I have 20 over 3, 6.666, whatever. Excellent. So that's function defaults. Now let's do the example of having lower and upper bounds for the function. So I'm going to clear everything. Delete. So define summation. Now the question is, let the user put two numbers lower bound and upper bound, and find the summation of all values between the lower and upper bound. We've done that using while loops or for, up to you. So I need to put summation lower, upper. So those are user inputs. Now let's write the code for summation as the way we learned, assuming that they have values lower and upper. So for num in range lower to upper. Okay, I need to have a variable for summation, sum. I will not write the summation. Why? Because I already called my function summation. So I'll use the sum. The sum, I start with 0. Summation problem, I start with the summation equals 0. So the sum plus equal num. Remember what plus equal means? Equal the sum equal num plus the sum, or the sum plus num. Or I'll keep it simple. I'll write it as a comment. The sum equal the sum plus num. Okay, so I did the summation. Do I need to do any printing? It's optional. I can do it beyond the summation. Another thing, what if the user put the upper bound lower than the lower bound? For example, I did summation of 10 and 5. Will it work? Will it work? So when you do range 10 to 5, will it give values? Let's do it here. Do you know how to access the contents of range? We've done that 2 weeks ago. List range 10 to 5. It's nothing. Unless I put -1, that's different. What's the -1 here? The step by -1. So my default, I should ensure that the lower is like the lower bound is lower than the upper bound. So if I'll go here, if lower is less than upper, then I can apply the condition. Else, print a message that upper bound should be lower than. So print lower bound should be less than upper bound. Okay, so return what? As I mentioned, each function should return. In this case, I return the summation. I should return the sum. Now don't get confused. I may have multiple returns in the same function. Okay, this one should not be then. Return not within the for, within the if. Else print, and in this case, return what? That's a keyword in Python, none. Return nothing. Oh, return 0. Return 0. That the summation is 0. Okay, so let's give it a try. Do I have errors in this function? So far, no. Actually, you cannot see the errors unless you call the function. So first of all, the function return how many values? 1. Each one return something. So it either returns the sum or 0, not both. It will return 0. It is a 0. it should return only one value, either the sum or zero. So in this case, so I will put result equal summation of 5 and 10. So what will be the result? 35. Is it correct? 5, 2. Why? So that's a logical error. How to fix it? Upper plus 1. I was off by 1. So in this case, I will get 45. But anyways, how can you confirm? Let's count. 5 plus 6, 11, plus 7, 18, plus 8, 26, plus 9, 35, plus 10, 45. Okay?
Return zero is necessary.
I'm expecting a return. Otherwise, if you don't return, like if this one, I did not put it. Let me try the other case of 20. Return 2010. What do you expect? 0. Because it will be this case. Return 0. And it will print a message. Lower bound should be less than upper bound, and the value is 0. What if I don't have this line? That's your question, right? Okay. It'll be weird, actually. It's none. And then the function did not reach a return, so it returned none. So it's not even an error, but it's in the message because I printed it. And I'm getting none. Okay? Is it clear how to play around with functions? So we'll go back to the slides and see where we stopped. By the way, usually functions must start with this thing. Do you know what this thing means? When you have 3 double quotations and you close it with 3 other double quotations. What do you call it? Docstring or documentation. And that's one of the main usages actually of docstring, is to document a function. What do you need to document? The purpose of the function, the inputs, what the function is expected to have inputs, and the outputs. So this function returns the summation of numbers between lower and upper bounds. Must be integers, for example. Lower and upper must be integers, and only return one value of the summation. All right, so this here, they did it with while. Perfectly fine. So what results equal 0, or the sum equals 0, while lower is less than or equal upper, do the summation and do lower plus equal 1. Range did that automatically for us. And that's it. It does not even check between lower and upper bounds whether they are higher or less. Okay. Slideshow from current slide. Display settings, duplicate. Functions serve as abstraction mechanisms. We did that. We just mentioned that. Now, by the way, now we check the summation function. That's it. I can call the function anytime, anywhere, as long as it's been, let's say, code, or it's within the code. I'll show you example in a few minutes that I have a total separate Python file, I call it utilities, that has auxiliary functions that I use for my own purpose, that I'm not worried anymore about the contents of that function. I call it, it does it. And sometimes when I go back to the function, I'll be like, God, I was smart by doing that some other day a few years ago. Because you will forget the content of that function. That's it. The function is done. It's a black box that does the purpose correctly. You don't have to worry about its technicalities anymore. Okay. So for example, this summation function, that's it. It works fine. I don't have to worry about it anymore. I don't have to worry about the algorithm of summation anymore. It does its purpose. So the idea of summing a range of numbers is simple, but the code for computing it is not that straightforward. So for example, like we did now in Spider, we did it with for loop. In the slide, they did it with while loop. Both of them are fine. But that's it. Once you've done it once, you don't have to worry about it anymore. A function call expresses the idea of process to the programmer without forcing him to wade through the complex code that realizes that idea. So you don't have to worry about the complexity of that code. It's hidden. And that's the purpose of functions. You had the complexity. Okay. So we've seen algorithms that they solve general methods. Algorithms should be general enough to provide solution to many problems. A function should provide a general method with systematic variations. Okay, division of labor, again, that's just some statements. Let's keep our focus on understanding what functions are, what, let's say, return means, some default values, and so on. So in a well-organized system, each part does its own job in collaboration to achieve a common goal. Basically, you divide the tasks, and each task, do it with a function. Let the function do a certain task for you. So you have the whole code to do a lot of things, but some portion of the code is for loading the data. So you create a function for loading the data. Another code will say do some cleanup to the data. So write a function to do cleanup. Another. So basically, your main code will probably consist of less than 20 lines. But within these 20 lines, each one of them has a function that has probably hundreds of lines. But you are sure that your function is correct. I don't have to worry about these 100 lines anymore. My focus on in these small lines, I made them as functions. Okay, so functions will do division of labor. Each of the tasks required by system can be assigned to a function. Function. Okay, arguments provide the function's caller with the means of transmitting information to the function. Programmer can specify optional arguments with default values. That's something we did now with the averaging example. Default values. If the function in any function definition. So follow the required arguments are one or more default or keyword arguments. When function is called with these arguments, default values are overridden by caller's value. So let me tell you an example or show you the example of finding the force. Do you know how to find the force? What do you need? In physics, mass and accelerations. So define force of mass acceleration. Now, as I mentioned, acceleration, some people consider it as 9.81 and some people consider it as 10. So I will consider 9.81. It's a constant. Yeah, acceleration force. Okay. Yeah, it's a gravitational acceleration, 9.8. But acceleration in general could be anything. But yeah, let's assume a free fall object, which is gravitational acceleration. Okay, so the function we have defined, let's go over it again. Defined as a keyword, def in Python. It means that I want to create a function. Force is the function name. I will open parentheses and put my inputs. By the way, the first input cannot be a default. I cannot put a default value of mass. If you put default, then basically Python will say like there's no use of your function. Your inputs have all defaults. So you cannot have a default value for the first argument. Acceleration, I'll assume we are doing a free fall object with a certain acceleration. All right. So that's it. And then F equal mass times acceleration. And I'm done. Return F. So I'm returning the force, the calculation of the force. All right. So F1 equal, I'll put force, the function name. For example, 6 kilograms. What will be the force in this case? 6 times 9.81, some weird number. Like 52 point something, 58 point something answer. 58. So somebody said, you know what, I will consider the acceleration as 10. to be pure 60. So basically, when you put 10 here, it will override the 9.81. If you don't put it, it will use the default. Okay, so that's the use of defaults. We did mention that order matters. Like the order matters in inputs. For example, 4, 6, and 10 by order, 6 will go for mass and 10 will go for acceleration. Now let's assume I have this code like this. INP1, like the first input, INP2, INP3, INP4 with 4 inputs, and I will give a default value for input 4 to be 10. Just a random function that I really don't know what it does. I'm gonna even call it random function. Random function. Okay, so I don't have this force. So this random function basically will do this. We'll find the summation of all the reciprocals. So basically the sum equal 1 over INP1 plus 1 over or no, actually will be complicated. Let's just summation of them. INP1 plus INP2 plus INP3 plus INP4. Okay, that's all. So that's a complete function that you feed it inputs and it find the output. So multiply to make difference, because adding them together will be no. All right, so we will go with this out equal random autofill. So input 1, input 3, input 2, input 3. What about input 4? Again, that's a feature in Spider, autofill. It considers that input 4 you have a default value, so it's not necessary, but I will put it. So I'll start with 1, 3, 2, and 5. Okay. So if we do the calculation for the output, I have input 1 equal 1 plus 3 times 1, 3. So 1 plus 3, that's 4, plus 5, that is 9. And if you remove this one, we have 10, so it will be 14. Because 1 plus 3 times 1, 4, plus 10, that's 14. Now, we did mention that order matters. How about sometimes you don't worry about the order, but you know your inputs? So in this case, I will say input 2 equal 3. Input 1 equal 1. Input 3 equal 3. And input 4 equal 5. So in this case, I'm not worried about the order, but I defined each input what will be the value regardless of order. So when this function go back to the function call, it will substitute each variable with the value I assign it. It's not about the order, it's about the value. So in this case, input 2 is 3, input 1 is 1, and input 3 is 3, and input 4 is 5. Let's do the calculations. Out is 15. How to confirm? So we have 2 and 3, they are multiplied. So 2 and 3, 3 by 3, that is 9. Plus input 1, plus 1, that is 10. Plus input 4, plus 5, that is 15. So in this case, I'm not worried about order. Okay? Even for this one, I'm not sure if I can do that. No, I have to mention what the value is be. So input 4. So once you do it, you have to do it for all variables. So we talked about defaults and now positional arguments. So I can change their position. It's not about mainly the order. Okay, so let's go back to the slides. Okay, so we did the default values. When the function is called with these arguments, default values are overridden by the caller's value. Okay, duplicates. So we did that already. The default arguments that follows can be supplied in two ways, by position and by keyword. We've done that already. All right. All right. So sometimes there are functions that you can, let's say, have a small, very small purpose that you don't need to define a function for them. That's what we call lambda functions. A lambda function is a small function that will get you the result in an instant. It's not a function call. It's like it doesn't even have a name. So lambda, variables, and the expression. So lambda is an anonymous function. Anonymous doesn't have a name. When the lambda is applied to its arguments, its expression is evaluated and its value is returned immediately. I don't have to define a function for that. By the way, lambda function, I cannot say, oh, the function name is lambda. No. A lambda function is a function that has no name, anonymous, that will do a certain task. For example, in a few minutes, we'll do multiplication of two variables. And that's it. It will return the multiplication in a single line. A lambda function is a single line function. All of the code must appear in one line code. And although it is sad, a lambda cannot include a selection statement because selection is like you need multiple lines for selection. For loop is there, but selections are not. But we'll keep it simple. We'll do like this function: f equal lambda a colons a times a, or a squared. So that's one will square a number. And in this case, I made a function called f, that f of 2 equal 4, f of 3 equal 9, and so on. So I cannot again say that, oh, the function name is f. F is like it's a holder, like as a placeholder that will hold the values for the function. So we'll go here and show it an example. So f equal lambda, and I need to define what is my variable, t. And the expression is 3t squared plus 5 times t plus 10. You know this equation? 3 times t. That's the position, right? And that's with respect to time. At squared plus t plus c, whatever. So that's like an equation of position. So I want to find the position of a function at a certain point in time. So I know the formula for the position, and I just need to substitute the time to find the value of the position. So let's call it p, since it's a position, and that's it. So p of 1, how much? So let's call it, it's 18. Here, the value is 18. Let's confirm. So for each t, so t squared is 1 times 3. 3 plus 5, that's 8 plus 10, 18. So that's it. I can still do something the same. Diff position t and p equal the same expression there. And return t and position of 1. Same thing. But lambda did it only with one line. I don't have to create a function do a return value, and so on. So that's a function with 3 lines. I did it with the lambda with only 1 line. I can do it with 2 variables separated by commas. So for example, I want to find the mean, not the mean, the algebraic mean. What is the other mean? Geometric mean. Geometric mean is the square root of multiplication of 2 numbers. So for example, I'll create a function here. Let's confirm geometric mean is, that's the name or not. Geometric mean. Yeah. And guess the central tendency. Take the cube root, geometric mean formula of 2 numbers. Yeah, geometric mean. All right, so GM equal lambda of X and Y. The formula is, I need to import the math. So math dot square root of X times Y. And import math. Okay, so I created my lambda function and geometric mean of, let's see, what would be good numbers for this example? 2 and 3 will be square root of 6. We cannot confirm. I want something that we can find the square root. 9 and 4. 9 and 4 is 36. Geometric mean will be 6. Again, that's a use of lambda function. And by the way, these are, as I mentioned from the beginning of the course, those are tools. It's not a must to do lambda. Like for me, I never did lambda in my research. I am comfortable with making a function that will do this. I'm fine with that. So sometimes also even in loops, like you can write a for loop in 1 line. It does work for me, but I never wrote it. ChatGPT did it for me and I tested it. It worked fine. I move on. Because it's not my purpose in the code. My purpose of the code, I want to do something more complicated. But there are these, tiny things in your code that you need them. So ChatGPT did that line for me. And I'm not ashamed of saying that because I can do it. I can spend 1 hour or 2 doing it. But why? It's like I want to save time, so I do it. I understand. I tested it and it works fine. So there is a way to write a for loop in 1 line. Is it mandatory? No. It's not mandatory. So these things here, they are tools. It's important for you to know, but are they a must for you to use? No. Depends on your purpose. Okay, so we'll go back to the slides. And these are the examples on Lambda. Display settings, duplicate. All right, so in summary, function serves as abstraction mechanism and eliminates redundant patterns of a code. A function hides a complex chunk of code in a single named entity, allows a general method to be applied in varying situations. So basically, functions decompose complex codes and divide them, like you divide the labor over small chunks of code, and you have a better and organized code. I will show you an example of my research. You don't have to understand anything. It's just to show you that these tools like functions are very important and are, let's say, in everyday use in some researchers. So for example, I have this utilities. I call it utilities. So I have a lot of imports there. I'm loading the data. So this is the function for loading data, and only I need to put the name of the data. So load data, that's the name, and it will do all this. So I have a selection statement based on my input. I'll select the data I'm loading. So I'll go to my main code. Okay, here. I have a lot of calls there. I even have this function. I can call it from there. And there you go, data set. That's the name of the data. And that's it. Call the data. Okay, still there. So look at my variable explorer. All. So I'm having how many outputs are there? We did not discuss it, but you can have as many outputs as you want. Like in this case, my function returned 4 things. It returned the data, it returned TE, TR, and class name, 4 outputs. If you want, let's clear everything here. Call it one more time. Data set is the input I did here. And here are my other 4 things. Let's call it. There we go. So I have my data loaded. Now there is another function called PCA. Apply PCA. And so it has inputs, data, num components, normalization. So there is a default value there. I change it to true. And if you go to the function apply PCA, somewhere here that I really don't care about anymore, that's it. I written it only once, and that's it. I don't literally this function, I call it every day, and I really don't know what's going on there. It does its purpose. And that's it. Apply PCA. Okay, I need to define the values, non-PCA. I'll tell you now. Okay, so it's done. So I have the variable data. And then this purpose. Now your friend asked a good question. I have my functions in a separate file. How to call them? I have it here. So I called my file utils. So from utils, import star. What does that mean? Import all functions from this utilities file. And that's it. Remember calling like import math. So to call all the math module like import math, but I need to do math.sqrt, math.something. In this case, no, I'm calling them all. So I don't have every time math.math. From this utilities, call all these functions. So it's as if I have these functions in my main code. So from utils import star, star means import all of them. If I want 1 or 2 functions, I remove the star and I put the names one by one. Now the difference when you have multiple returns, that's it, simple. So instead of return only single thing, return data, trgt, tegt, class name, and separated by commas. So that's an example of function. Now imagine I want every code I want to do, I have to do this part. That's kind of, let's say, time consuming, or even copying and pasting. Sometimes while copying and pasting, due to indentation, something bad will happen. Like you will get a syntax error because of indentation only. But by doing this, I have a function. I'm kind of, let's say, less, there is less room of errors. The function is there, it does this work, that's it. So that's the importance of functions. Once you move on, inshallah, if you take AI courses, computer vision courses, this kind of things really help. All right, so that's it for today, actually. As I mentioned, the lecture is short. So let me stop the recording. Okay, stop.